Something unusual has been happening beneath Yellowstone National Park, and scientists are watching it very closely. Over the last few years, researchers monitoring the area detected increasing earthquake swarms, unusual heat activity, underground pressure shifts, and deformation of the ground itself. Individually, these signs are not enough to suggest a major eruption, but together, they point to something much more complicated happening under the surface. And according to newer geological models, Yellowstone may not behave like a single volcano at all. Instead, scientists now think there could be multiple smaller magma systems and volcanic zones spread beneath the region, some of which may be slowly becoming more active. Yellowstone already sits above one of the largest volcanic systems on Earth. Beneath the park lies a massive underground magma reservoir stretching for tens of kilometers. This is what powers the geysers, hot springs, mud pots, and constant geothermal activity visitors see every year. But modern seismic imaging has revealed that the underground structure is far more fragmented and complex than researchers once believed. Instead of one giant pool of molten rock, scientists are now seeing evidence of multiple magma pockets, underground fracture systems, and networks of superheated fluids spread throughout the Yellowstone region. Some of these pockets appear partially connected, while others may behave more independently. That changes how scientists think the entire system works. One of the clearest warning signs comes from earthquake swarms. Yellowstone experiences thousands of small earthquakes every year, but some swarms are unusually concentrated. In certain cases, hundreds of small quakes occur in the same area over only a few days or weeks. Most are too weak to be felt by people. However, earthquake swarms often indicate that underground fluids, or magma, are moving through fractures beneath the surface. And recently, several swarms occurred near active geothermal regions, where heat flow is already unusually high. At the same time, scientists observed sections of the ground slowly rising and sinking over time. Using satellite measurements and GPS stations, researchers detected uplift of several centimeters in some areas over periods of years. That may not sound dramatic, but ground deformation is one of the key indicators volcanologists monitor because it can signal changes in underground pressure. The most likely explanation is movement of hot fluids and partially molten rock beneath Yellowstone. Researchers have also documented changes in thermal activity. Some hot springs became hotter than usual, new steam vents appeared, and certain hydrothermal areas showed stronger gas emissions. Yellowstone's geothermal system constantly changes naturally, but the pattern of activity has become more interesting as more underground imaging data becomes available. And this is where the story gets strange. Some volcanologists now think Yellowstone behaves less like one centralized volcano and more like a distributed volcanic network. In other words, instead of one massive eruption point, the park may contain multiple smaller volcanic zones capable of localized activity. That means smaller eruptions, hydrothermal explosions, or lava events could theoretically happen without triggering a full supereruption. This is important because hydrothermal explosions are actually considered one of Yellowstone's more realistic geological threats. These explosions occur when underground water becomes superheated and suddenly flashes into steam, creating violent pressure releases. Past hydrothermal explosions at Yellowstone created craters hundreds of meters wide. Some researchers believe the movement of heat and fluids between multiple underground magma pockets may increase the complexity of these events. Seismic scans suggest parts of Yellowstone's magma system extend deeper and farther than previously estimated, with interconnected fractures allowing heat to move across large areas underground. This may explain why activity sometimes appears in different parts of the park at nearly the same time. Of course, the idea of Yellowstone waking up immediately brings attention to the possibility of a super eruption. The last major Yellowstone eruption occurred around 640,000 years ago and spread volcanic ash across huge parts of North America. But scientists are very clear about one thing. There is currently no evidence that a catastrophic super-eruption is imminent. Modern monitoring systems at Yellowstone are among the most advanced volcanic surveillance networks in the world. Seismometers, satellite imaging, gas sensors, thermal cameras, and underground mapping systems constantly monitor changes beneath the park. Right now, researchers say Yellowstone does not show the large-scale warning signals expected before a massive eruption. However, scientists also emphasize that Yellowstone is absolutely not dormant. It is an active volcanic system continuously changing beneath the surface. And the discovery of multiple underground magma zones suggests the entire region may be much more geologically dynamic than researchers understood just a few decades ago. Which means the strange activity being detected today may not be coming from one volcano beneath Yellowstone, but from an entire underground network slowly shifting below the park.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hot spots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it. A cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain two parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the two of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
Yellowstone is often called the most dangerous volcano in North America. But what makes it unusual is that you cannot see the volcano itself. There is no giant cone or mountain rising above the landscape. Instead, the entire national park sits on top of a massive volcanic system hidden deep underground. And recently, scientists studying Yellowstone have been paying close attention to several strange signals coming from beneath the park. The ground in some areas has slowly risen. Large clusters of small earthquakes have appeared, and new seismic studies suggest the magma system below Yellowstone may be far more complex than researchers once believed. Some scientists now think Yellowstone may not behave like a single volcano at all. Instead, it could be part of a much larger underground volcanic system with multiple magma pockets and smaller volcanic structures connected beneath the crust. That idea raises an obvious question. If Yellowstone becomes active again, could it involve more than one volcanic event? To understand why Yellowstone attracts so much attention, it helps to look at what actually sits beneath the park. Yellowstone lies on top of a volcanic hotspot, a region where extremely hot material rises from deep inside the Earth's mantle. As this heat moves upward, it melts parts of the crust and creates large reservoirs of magma. Unlike typical volcanoes, Yellowstone does not erupt from a single mountain. Instead, it forms what geologists call a caldera, a huge collapsed volcanic basin created by past eruptions. The current Yellowstone caldera is roughly 70 kilometers long and 45 kilometers wide. That enormous depression formed after the most recent major eruption about 640,000 years ago. But that was not the first time Yellowstone erupted on a massive scale. The region has produced 3 giant eruptions over the past 2.1 million years. The oldest of these occurred about 2.1 million years ago and created the Island Park caldera in Idaho. Another massive eruption followed roughly 1.3 million years ago, forming the Henry's Fork caldera. The most recent supereruption created the Yellowstone caldera we see today. Each of these events released enormous volumes of volcanic material. Ash from those eruptions spread across large parts of North America, and some deposits can still be found thousands of kilometers away. Because of this history, Yellowstone is often described as a supervolcano. A supereruption is defined as an eruption that ejects more than 1,000 cubic kilometers of material. For comparison, the 1980 eruption of Mount St. Helens released about 1 cubic kilometer. Despite that dramatic history, Yellowstone today is not silent. The region remains one of the most geologically active places in North America. Every year, the park experiences hundreds to thousands of small earthquakes. Most of them are too weak for people to feel, but they provide scientists with valuable information about what is happening underground. The park is also home to more than 10,000 hydrothermal features, including geysers, hot springs, and steam vents. These features exist because water deep underground is heated by the magma system below the surface. Another signal scientists watch closely is ground deformation. Over the past several decades, parts of the Yellowstone caldera have slowly risen and fallen as magma and fluids move beneath the crust. Satellite measurements show that in the early 2000s, some areas of the caldera rose by almost 25 centimeters in just a few years. That kind of movement usually indicates that pressure is building somewhere underground. Then there are the earthquake swarms. Unlike typical earthquakes, which involve one large quake followed by aftershocks, swarms consist of many small earthquakes occurring close together over a short period of time. Yellowstone experiences these swarms fairly often. One of the largest recent swarms happened in 2017, when more than 2,400 earthquakes were recorded over several months near the park. Scientists believe these swarms are often caused by fluids or magma moving through cracks deep underground. By studying how seismic waves travel through the crust, researchers have been able to create detailed images of the magma system beneath Yellowstone. And these images revealed something surprising. Instead of one giant magma chamber, Yellowstone appears to contain multiple magma reservoirs stacked beneath the park. The upper magma reservoir sits roughly 5 to 17 kilometers below the surface. Beneath that lies a much larger reservoir extending down to about 45 kilometers deep. Together, these reservoirs form one of the largest volcanic magma systems ever detected beneath a continental volcano. However, the system is not a giant pool of liquid magma waiting to erupt. Studies suggest that only about 5 to 15% of the upper reservoir is actually molten rock. The rest is mostly solid rock heated to extremely high temperatures. That detail is important because for a large eruption to occur, scientists believe the magma chamber would need to contain 40 to 50% molten material. In other words, the system would have to undergo major changes before a super eruption becomes possible. But smaller events are a different story. Yellowstone is capable of producing hydrothermal explosions, which occur when superheated water trapped underground suddenly turns into steam. The rapid expansion can blast rock and debris hundreds of meters into the air. These explosions have happened many times in the park's history. Some of them created craters hundreds of meters wide. One ancient hydrothermal explosion formed a crater nearly 2 kilometers across. While these events are far smaller than a volcanic eruption, they can still be powerful and unpredictable. Another discovery has made the Yellowstone system even more interesting to scientists. Recent geophysical surveys suggest the magma beneath Yellowstone may be connected to a broader network of volcanic activity across the surrounding region. The Yellowstone hotspot has actually left a long trail of volcanic formations stretching across parts of Idaho, Nevada, and Oregon. As the North American tectonic plate slowly moved westward over millions of years, the hotspot produced a chain of ancient volcanic fields across the western United States. Today, Yellowstone sits at the newest end of that volcanic track. But deep beneath the surface, magma rising from the mantle may spread outward into smaller pockets and fractures throughout the crust. Some researchers think these smaller magma pockets could feed localized volcanic or hydrothermal activity in the broader region around Yellowstone. That does not mean multiple volcanoes are about to erupt, but it does suggest the underground system feeding Yellowstone may be much larger and more complicated than scientists once imagined. Because of this complexity, Yellowstone is one of the most heavily monitored volcanic systems in the world. Scientists track earthquakes using dense networks of seismometers. GPS stations measure even tiny movements of the ground. Satellites monitor the landscape for changes in elevation. So far, these monitoring systems show no signs that a major eruption is imminent. But the discoveries made over the past 2 decades have changed how researchers understand Yellowstone. Instead of imagining one giant magma chamber waiting beneath the park, scientists now see a huge underground network of magma reservoirs, heated rock, and circulating fluids. That system is constantly shifting and evolving. And while Yellowstone is not expected to erupt anytime soon, it remains one of the most powerful volcanic systems on Earth. The geysers, hot springs, and steaming ground visible across the park are reminders that deep below the surface, enormous amounts of heat are still moving through the crust. Most of the time, that energy escapes quietly through hydrothermal activity. But the deeper scientists study Yellowstone, the clearer it becomes that the system beneath the park is far more complicated than anyone once thought.
Yellowstone's alert level is currently green, but don't get too comfortable. This supervolcano is still alive, and it could erupt at any time. New data shows the caldera is breathing, with the ground slowly rising and falling as things move deep underground. If Yellowstone actually blew today, it would be a huge disaster. A 10-foot layer of ash would bury everything as far as 1,000 miles away, and over 90,000 people would lose their lives almost instantly. Now, the problem is there's some strange activity going on there lately, like the rare Norris Geyser erupting all of a sudden. This is the biggest acidic geyser in the world that measures about 60 feet across. Think of it as a hot spring that shoots up acid. It's also scorching hot, with temperatures that can get over 200 degrees Fahrenheit. The Norris Geyser was really active back in the 70s, and it used to erupt every 40 to 80 minutes. But it stayed quiet for the last 6 years until it erupted again in February 2026. The water shot 30 feet high, and the eruption lasted about 3 minutes. It was quite a show. But people were worried. I mean, is this a sign the volcano is finally waking up? Well, probably not. Geysers turn on and off all the time. That's just typical Yellowstone behavior. But Norris isn't the only hot spring out there that's been acting a little weird lately. So, Yellowstone was the first national park in America, and it sits right on top of an active supervolcano. That's why there are over 500 active geysers over there. Basically, they're hot springs that get heated up underground and shoot water and steam into the air every so often. These geysers are shaped like a long tube or a hole that goes deep into the ground and fills up with water. Since the water at the very bottom is so close to the magma, or molten rock, it starts to boil. That pressure forces the water up and out in an eruption. Then the water slowly drains back down, and the process starts all over again. Having all these geysers around means the park is basically covered in steam, so it has this really mysterious, misty feel to it. And now it just got even cooler. The ground is literally moving. Lately, everyone's been focused right here, on the Norris Geyser Basin. This spot is home to the Steamboat Geyser, the tallest active geyser in the world. And since 2025, scientists have noted something weird here. The land, which used to be flat, now has a bulge in it. Yep, the ground has pushed up by about an inch along the northern rim of the Yellowstone caldera. But we don't have to worry about Yellowstone finally erupting and destroying the planet. I mean, the situation is pretty scary, sure, but it's not a direct sign that an eruption is on the way. To be fair, this is not even a new phenomenon. Between 1996 and 2004, the land did the exact same thing. The area just south of the Norris Geyser Basin rose by almost 5 inches. This happened because a huge pool of magma, about 9 miles deep, was pushing up from underground. It felt like Yellowstone was ready to erupt at any time. Everyone was terrified, thinking it was the end of the world. But nothing happened. Then, in late 2013, the ground started rising again, at a rate of about 6 inches a year. and that was faster than ever before. Everyone got super nervous all over again. But just like last time, nothing big happened. The event lasted until 2014 and ended with an earthquake with a magnitude 4.9. That was actually the largest one in the area since the 70s, but it didn't trigger a massive eruption. In fact, the last time Yellowstone actually erupted was about 70,000 years ago, and it was not even a huge blast. Now, the area where this happens is known as the Norris Uplift Anomaly, and scientists are getting pretty used to its strange behavior. They say that when magma moves into the Earth's crust, it cools down and releases trapped gases. As that gas escapes, the pressure drops and the ground sinks back down. But just when we thought the area was finally quiet, nah. Back in July 2025, scientists checked the data and confirmed it. The land was rising again. The whole process looked very similar to the one back in the 90s. This might also explain the sudden rise in the number of earthquakes in 2025. I mean, the year was actually pretty quiet overall, with only about 1,100 earthquakes. That's pretty low, considering that at least 1,500 happen in a normal year. But the number of earthquakes suddenly went up at the end of 2025, and most of them happened right near the anomaly. So scientists were pretty sure the two things are connected. According to the estimates, it looked like the ground was going to keep rising for a while. But they also said we don't need to worry about an eruption. The changes we've seen so far are actually pretty small. They're nothing compared to the warning signs we'd get if Yellowstone was really about to blow up. Plus, we have way better tools now than we did in the 90s to track all these ups and downs. But one thing we know about volcanoes is that they are unpredictable. So against all the projections, something strange just happened. The ground stopped rising. Exactly. Recent measurements show the upward movement that had been happening since July 2025 has paused. So, whatever was going on under the Norris Geyser Basin just ceased, for now at least. Then there's something else that shows the caldera is back to normal. In February 2026, there were 74 earthquakes out there, which might sound like a lot, but for Yellowstone, it's not. That's a pretty standard number, because about half of the earthquakes in the park normally happen in swarms. I mean, groups of quakes that hit the same spot around the same time. And these swarms can trigger 10 tiny quakes in an hour, for example. To give you an idea, the year with the most earthquakes was 2017. That year, we were seeing something like 285 earthquakes a month. And even then, that wasn't considered dangerous activity. So, if February only had 74 quakes, we can consider it supernormal. Okay, so the caldera looks like it's quiet again. Does that mean we're safe and Yellowstone won't blow up? Not really. Then again, volcanoes are totally unpredictable. Yes, I'm repeating myself. But even with all the high-tech tools we have today, we don't exactly know how they will behave. So, technically, it can erupt at any time. Now, some people might think that Yellowstone is overdue, but that's not really how it works. If you look at the map, there's an average of about 725,000 years between its big eruptions. Based on the last time it had a big blast, we've technically got another 100,000 years left. But honestly, that average doesn't mean much, because volcanoes don't follow a schedule. Now, if Yellowstone did blow, it would be a total disaster. Some say it would be way more powerful than anything humans have ever seen. Computer models show it would blast tons of ash and toxic gas into the sky, making it almost impossible to breathe. That ash could even reach Europe in 3 to 4 days. The magma would completely wipe out the region, swallowing up forests, rivers, mountains, and anything else in its path. But scientists say the chances of an eruption are super tiny. And there's more. One of the magma chambers under Yellowstone is only about 5 to 15% liquid. The rest is basically solid rock. Hot rock, but still. It's not even clear if there's enough runny magma down there to cause an eruption in the first place. Anyway, that doesn't mean we should completely relax. Experts are still keeping an eye on the Norris Geyser Basin to see if anything changes in the coming months. Actually, the whole volcano is constantly monitored, and this situation is just another reminder that Yellowstone is still very much alive.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers. Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-feet layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock, known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.